All right, guys, I am here today to settle the debate once and for all between C-style casting and static casting. Different C++ programmers have different preferences. I'm here to say that one is the definitive answer, and I'm going to defend that right now. So we can see here in Compiler Explorer, I've created two functions that compare these two ways of casting. They both have an unsigned long, a fudge that I set to 7, and they both cast it to an int. So one uses the static cast, one uses the C-style cast. But if you turn to the right here, you can see that the assembly code that is generated is exactly the same. There is no difference between the two from the computer's perspective. So how can we say one is better? Let us turn to the CPP core guidelines. If you haven't bookmarked this page yet, please do. Just Google C++ core guidelines. If you're ever unsure about something, if you're ever not sure whether I should do this tool or this tool, which way to go about solving a problem, you can always defer to this document. They will literally give you a concrete answer and say, do this, use this one in this case. And that is what they do here. They say, if you must use a cast, use a named cast. In other words, one of the C++ built-in casting tools such as static cast, const cast, reinterpret cast, dynamic cast. At other points in this document, of course, as you might imagine, they're very much red flagging reinterpret cast. That's a huge problem, but it's definitely a tool in the toolbox that can be used in certain situations. They give some examples of misuse of casting down here. But basically, yeah, I mean, there's right here is some C-style casting where they say like, okay, this is a legal cast, but it isn't clear in the standard what is supposed to be done. So basically, there are casts that you can do that might compile and might run, but then you might not run into the error until runtime, whereas the static cast would catch that error whenever you try to compile it. So while the assembly code might end up being the same, there is something to be said about catching errors, catching bugs early before actually running the program. So let's take a moment and create a crazy example to sort of demonstrate this. Now, instead of doing an unsigned long, let's do an unsigned long pointer. I'm not going to set it to anything. It's just going to be uninitialized. Some compilers will actually cast this to an int. They'll cast an unsigned long pointer to an int, which is somewhat gibberish if you think about it. The one I'm using at the moment does not. So we'll use a less extreme example. This is bad C++ code. I would not recommend doing stuff like this. But my point remains, this compiles what I just did. This is a sort of backdoor reinterpret cast, but without any, without any of the safety of the C++ behind it. So let's see out the result of this function now. And we can see we got this number here. Okay, so this is what fudge evidently is. However, if we take a step back, let's actually see out at when it's first here, when it's first declared, and it's an uninitialized variable. Oop, gotta dereference it. It's an uninitialized variable, so this is garbage data. I could have also assigned it, but for the sake of this, let's just see what the garbage data is. It's this very big number. And yet, whenever I cast it to an int pointer and then dereference it, I get this completely different number down here. Why is that? It's because, well, an unsigned long is 64 bits long, or 8 bytes, but an int is 32 bits long, or 4 bytes. I'm literally taking the data and cutting it in half and only looking at the first half, and also going from unsigned to signed. These two data types are apples and oranges. They are completely unrelated to each other, more or less, except that they are numeric and deal with integers. So it's no wonder that the results of this sort of forced cast is completely different. But what if I tried to do a static cast here instead for this crazy example? Let's do a static cast to int pointer. So it's the same type. I'm still trying to cast to an int pointer, and it doesn't compile. It catches the error. It says I'm trying to static cast from unsigned long pointer to int pointer is not allowed. It's very clear what the error is. I got a nice little underline there. It doesn't let me do it. It caught the error at compile time. Honestly, that's it in a nutshell. There is no upside to a C-style cast except maybe it's slightly more readable, but there is some upside to a static cast. There are situations where it is useful. It has things about it that the C-style cast does not have. So definitively, objectively, it is the better tool to use in most situations, except if your only goal is to write shorter, I guess, quote unquote, cleaner looking code. So I think that's it in a nutshell. I thank you so much for watching. Please like and subscribe if this was helpful at all, and comment if you disagree or agree. Thank you so much. Have a great one.